Today I am going to start with the bio chapter, Cell, the basic unit of life. Today let us learn about cell, the invention of microscope, discovery of cells, the size, the shape and the number we will discuss today. Cell. Cell is the smallest building block of all living organisms. And cell is the structural and functional unit of all living organisms. So cell is the structural and functional unit of all living organisms. Cells actually we cannot see with our eyes. So cells can be seen only through microscope. Microscope is an instrument used to see tiny objects which we cannot see with our naked eyes. We can see through microscope. So that is the purpose of using a microscope. Now let us see the invention of microscope and discovery of cells. The invention, that is Anton van Leeuwenhoek, is he proposed or he developed a simple microscope. He developed simple microscope with a single biconvex lens. That is the microscope that is made up of single biconvex lens. So with this, using this microscope and using with this simple microscope and single biconvex lens, he saw bacterial cells, he saw the human red blood cells, etc. He is considered as the father of microbiology. So Anton van Leeuwenhoek is considered as the father of microbiology. He is considered as the father of microbiology. Now let us see the next one, that is in 1665. Another scientist, that is the Robert Hooke. Robert Hooke developed primitive microscope. Primitive microscope, that is Robert Hooke proposed a primitive microscope or developed a primitive microscope made up of two lenses. He observed the thin slice of cork. Cork means that is the dead cell. So he took the slice of the cork cell and he placed it under the microscope and he observed. When he kept it under the microscope, he saw that there are tiny box-like compartments called as cells. So he found tiny box-like compartments like this. So he found like this compartment, tiny box-like compartments with empty space filled in it. So empty space. This is empty space, you can see. So this was given the name as cells. So this was given the name as cells, which is derived from the Latin word that is called as cellular. Latin word called cellular, which is known as, or which you mean, cellular means small homes. Cellular means small home. So this tiny, that is, these tiny box-like compartments are called as cells. They are known as cell, and this cell was derived from the Latin word that is known as cellular, which cellular means small homes, small homes. So this was his view, that is Robert Hooke. Robert Hooke in the year 1665. Now let us see the next one, that is the Malthus Schleiden and Theodor Schwann. That is Schleiden and Schwann. Malthus Schleiden and Theodor Schwann in 1838. In 1838, they said that, or they put forward the cell theory of life. They put forward cell theory of life. Cell theory of life. I'll write it clearly. Cell theory of life. And these scientists, that is Schleiden and Schwann, they said all plants and animals are made up of cells. And cell is the basic structural and functional unit of all living organisms. Now let us see the next scientist, that is Rudolf Virchow. In 1868, he proposed the cell theory. Schleiden and Schwann, they put forward. But this was proposed by who? Rudolf Virchow. Rudolf Virchow proposed cell theory of life. He stated that all new cells are produced from the pre-existing cells. All new cells are formed from the pre-existing cells. So this is about the invention and discovery of cells. Yes? Now let us see the size, the number and the shape of cells. First, let us have a look on size. The size of a cell is measured in micrometer. The size is measured in micrometer. So size is measured in micrometer. Write it in micrometer. Yes, size of a cell is measured in micrometer. The size usually varies. The size of a cell usually varies. That is from small cell of bacteria to large nerve cells. The size of the cell usually varies. The size of the small cell, that is from bacteria is about 0.2 to 5.0 micrometer is micrometer to nerve cells which is about 1 meter long. And the largest cell that is found in nature is the egg of ostrich, which is about 15 centimeter long and 13 centimeter wide. So this is about the size of a cell. Now let us have a look about the number. That is, organisms may be unicellular or multicellular. Unicellular means their body is made up of single cell, and multicellular means their body is made up of many cells. Example for unicellular, that is bacteria, amoeba, all these are examples for unicellular. And multicellular, human being. Human being is a multicellular. Now let us have a look at the difference between unicellular and multicellular. Yes, unicellular and multicellular. Now unicellular and multicellular. Yes. So unicellular, I've already said unicellular means the body is made up of single cell. Unicellular means the body is made up of single cell. Multicellular means the body is made up of many cells. It is made up of many cells. Now second difference is in unicellular, they are microscopic. Microscopic means which you cannot see with your eyes. So they are microscopic. Yes, whereas in multicellular, they are macroscopic. Macroscopic means which you can see. Yes, with your eyes, macroscopic. Now third difference is single cell. Single cell performs all life functions. Single cell performs all life functions. Whereas in multicellular, different cells are used to perform different functions. For example, human body. Human body have different organs, right? Each organ perform different functions. Kidney perform different function, heart performs different function. So, different functions are performed by different organs. So, different cells varies to perform different functions in multicellular. So, different cells are used. Different cells or different life functions are found to be brought by various cells. Okay, so this is about the multicellular. So different functions performed by different cell, that is organs, tissues, organ system, etc. So this is about the third difference. And now the fourth difference, that is about unicellular and multicellular. Unicellular have simple body organization. Simple body organization. Whereas in multicellular, complex body, because their body is made up of many types of organs. So it is complex body organization. And unicellular, they have very short lifespan. Lifespan is very short. They live for very short time. And whereas multicellular, they live for longer period of time. Yes. So these are the differences between unicellular and multicellular. So I will explain once again and we'll just have a look. Children, first is the unicellular, their body is made up of single cell. Multicellular, their body is made up of many cells. Yes. Second one is organisms are mostly microscopic, whereas in multicellular, the organisms are mostly macroscopic. Then single cell perform all life functions, whereas in multicellular, different life functions are performed by different organs and organ system. And fourth function is the simple, unicellular have simple body organization, and whereas in multicellular, complex body organization. And unicellular, that is, they live for a very short period of time. Lifespan is very short, whereas in multicellular, lifespan is very long. cells. Okay, the shape usually varies. They vary from one cell to another. So each cell have different types of shapes. Nerve cell, for example, nerve cells, they are elongated cells. Yes, nerve cells, they are elongated cells, and their main function is to send electrical signals as impulses throughout the body. So nerve cells, they are elongated cells. Nerve cell, what is the shape? They are elongated cells. And what is the function of the cell? They send electrical signals. They send electrical signals as impulses, as messages. Impulses throughout the body. So that is the main function of nerve cells. Now the skin, that is skin cells. Skin cells are usually flat. They are flat cells. Skin cells are usually flat, and so that they can act as a barrier, as a protective covering. So that is the main function of skin cells. So skin cells are flat cells and they act as a barrier, as a protective cover. Now next let us see human red blood cells. That is human red blood cell. Human red blood cell. Yes, that is RBC, human red blood cell, that is RBC. RBC is actually biconcave disc-like shape. So it is biconcave disc shape. The cells are having disc-like shape. Yes, and the main function of this is providing greater surface area for absorbing oxygen. So main function of this human red blood cells, that is RBC, the main function is provide a greater surface area. Why? For absorbing oxygen. That is the main function of RBC. And next is the white blood cells. So we have seen red blood cells, now white blood cells. White blood cells are irregular in shape. They don't have a particular shape. Their shape will be irregular. They are irregular in shape. That is why they can squeeze out through the blood capillaries. They can squeeze out through the blood capillaries to fight against infection causing germs. Understood? They can squeeze out through the blood capillaries and they can fight against infection causing germs. So this is about the shape of cells. So we have already discussed different cells have different shape. That is nerve cells are elongated cells. Then skin cell, that is skin has flat cells. And human red blood cells, they are biconcave and disc shape. And white blood cells, they are irregular in shape. So cells vary in their shape. Yes, students, so today we have learned what is cell, what are the different discoveries of cell, about different scientists, and then we have learned about the cell size, shape and number. So with this, let me wind up for today.